Timberland.
That's an intruder sound.
Oh, Devin just is my little theatrical boy.
What does he do for Power Cup?
He
gives us
But
plays.
isn't he?
He's only a freshman.
No junior would
No
do it.
juniors would do it.
Oh.
Devin.
Devin stepped up to the plate.
Here we go. So, we are on the last problem. Yay.
Yeah.
Okay, we started yesterday talking about how to find the range of it. Did we finalize that? We went from negative 3 to 5 or negative 5 to 3? Okay.
Yeah.
So do you guys understand how that happens? Where you look at your domain and assess your range from it. Okay. Next thing is find the coordinates of the points at which the curve y equals f of x intersects the coordinate axes. So what does it mean by coordinate axes? Yes?
The X and Y.
The x and y. So you're actually looking for the x-intercept and the y-intercept. So you're looking for the place that causes the x to be 0, and you're looking for the place that causes the y to be 0.
What did we say the range was?
Okay, so the range, the way we work that is we looked from negative pi over 2 to pi over 2. Okay? On your unit circle. So negative pi over 2 is this, pi over 2 is this. So what I suggested is plug in negative pi over 2, plug in 0, and plug in pi over 2. And the values that you get out from there are negative 5 to positive 3. And notice that these have including them, the pi over 2 and the negative pi over 2. So your range would also be including them. Okay, so keep that in mind. If this at the beginning had strictly said from less than and less than, then you could say negative 5 to 3, but you wouldn't use less than or equal to. You would just use less than.
But for this, we do use less than or equal to.
Right. Okay, so there's your range. Now let's move on.
Yeah.
The next part says it wants to find the coordinates of the points at which the curve intersects the y and the x-axis, the coordinate axes. So you're going to take 4 sine of x minus 1, and you're going to do two things to it. The first thing you're going to do is you're going to set it equal to 0. You want to set it equal to 0. That means y is 0. So which one would I be finding when y is 0? Your x-intercept. And then the next step would be solve when x is 0. Are we good so far? So you're going to take sine of x equals to 1/4. Everybody okay? So what's your best way to do that? Plug it in your little calculator. What should I be in?
Radians.
I should be in radians. Why?
Because it's pi.
Because this had pi in it, right? It started with telling you in pi. If it said degrees, then you would be in degrees. Okay? So, yeah.
I thought you were solving for x.
We are. How do you solve for x?
Don't you have to do the inverse?
Yeah, that's great. So x equals inverse sine of 1/4. And you're going to make sure you're in radian mode. 0.25.
More, is more, but
Okay.
Okay.
You did 3, so it would be like...
Give me one more.
0.253.
Okay, so 0.253. All right, so we are there at 0.253. I know that the answer I'm looking for is where sine is positive. So where is sine positive? Sine is positive where and where?
Your sine is positive in the third and fourth, or first and fourth.
First,
Yeah. Or first and second.
second. What is sine equal to?
Y.
It's y, so it's where y is positive.
Yeah.
So where y is up here, right? So, well, it just says here, sine of x equals 1/4, right? Positive 1/4.
Mm-hmm.
Okay.
Yeah. All right. Okay. Yes. Say it again. Here. Okay, but the question I ask now is, could there have potentially been a second value? In the real world, when we're doing these problems, we always say, okay, 0.253 is one of my answers. There might be a corresponding answer. And the reason why I want to go through this is because in this particular case, the answer that would be in this quadrant would be eliminated, if there was. Why is that? It's a really good question. No? what was the actual constraints that they started with? Where should my answer fall from the very beginning?
Negative.
Here
okay.
and here, right?
Yeah.
So over here would have been like no land.
Right.
So the fact is 0.253 is the only answer that I could have utilized. Because remember, in the real world, if sine equals 1/4, it would have been here and here.
Yes.
But that's not an option. And it really wouldn't have really made sense for it to be an option if we're looking for the place at which it crosses the coordinate axes, if that makes sense, what I'm trying to say.
Yeah.
It should only be one. But I want you to be aware that potentially in other types of problems it could have happened. Okay, so now how do we go about the other? We let x be 0. So
Yep.
4 sine of 0 minus 1 is. Well, what is the sign at 0? The sign at 0 is 0. So 4 times 0, so it's -1. So what do we think?
And that we just gained 3 points.
We're good. We're very good. Now it wants us to sketch the graph. Okay, so sketching the graph. Let's talk a little bit about something for a minute. If I told you to sketch that, okay?
Yeah.
First of all, x squared is a regular parabola. What does the 4 do to it?
Stretch it upward.
Makes it stretch upward. Remember, it makes it very, very, very skinny,
Yes.
right? Elongates it in some nature. And what does the -1 do to it?
Brings it down.
Shifts it down. Yes.
I'm saying the -1, that means that the y-intercept is -1.
Goes down.
That's where the vertex is.
Right.
It'll be -1, 0 in this case.
In this case.
Or 0,
negative
yeah.
one. Right, 0, -1. Right. So, okay, so in the x squared world, we know how to grasp it. Sometimes we see 4 sine of x minus 1 and we get nervous. So let's, for the fun of it, from -pi/2 to pi/2 is what we're worried about. Okay, because that's all it wants me to graph, right? But I want to do a little more just to see what's happening. So let's kind of review what sine looks like. Okay, so in just plain sine of x, what does plain sine of x look like? Where does it start? Where does it go up? Where does it end? Bless you. So actually I'm going to make, because I don't have a lot of room here, I'm going to make this pi and this 2 pi. So therefore that would be pi/2 and that would be 3 pi/2. And this is in the real world, right? I just don't care about this one for now. I want to know what the regular sine of x graph looks like. Anybody remember? Where does it start? Which direction does it head? Nobody knows. Yeah,
Doesn't it look kind of like a wave?
it is a wave.
Does it repeat every 2 pi?
Okay, let's see. Look at 0. What is sine at 0?
Pi/2. Or,
Sine at 0.
or 0.
0.
2 pi.
0. Okay. So at 0, this is, I'm graphing right now y equals sine of x.
Mm-hmm.
0, 0. Okay? Let's move up. At pi/2, what is the sign? Oh, okay, it's 1. So at pi/2, it goes up to 1. At pi, what is the sign? 0. So it comes here. Okay? At 3 pi/2,
3 pi/2, it's,
-1.
-1.
Negative
So
one.
it comes down. And then at 2 pi.
then at 2 pi, it's going to be 0.
Okay. So a normal sine wave comes up, goes down, comes up. Okay? Yes.
Is that where, I've heard in physics, the sine wave, is that
Same thing?
what that is?
Mhm.
Mm-hmm.
Yes.
So to do that, you just went to like the 90-degree angle and then 180 and
Yeah.
370.
Right, because 90, 180, 270, 360.
Okay.
And what do you think happens at -pi/2?
Goes down.
So yeah, because it's at -pi/2, right? It's -1. So it's coming down here, right? And then it comes back up. So it goes like this. So a sine wave is actually what we call periodic
Mm-hmm.
and cyclical. Right here to right here, it's one full period. It comes down and goes up. Okay?
Mm-hmm.
And then it goes up and down. It continues. It continues its little job. So this could go on forever, endlessly, both ways. So the way that sine looks, just an FYI, so we have y equals a sine of bx. okay? The A is what we call the amplitude. Amplitude, think about that. If you amplify something, what do you do to it?
Make it larger.
Make it larger, right? Okay.
Yeah.
So the amplitude is how high or how low it goes, how skinny it gets. Okay? Yes?
I remember amplitude from physics, the difference between the crest and the trough.
Same thing.
Yeah.
Same thing. Right. So if I'm looking at a normal sine wave, y equals sine of x, its amplitude is 1. It goes as high as 1
Mm-hmm.
and as low as -1. The crest and the trough.
Mhm.
Very good. Okay. Now, the B, this B guy here. So the B is what we call the period. Okay? The period is 2 pi divided by B. Okay? So in a regular sine x graph like this, the thing in front of x here is a number 1, right? So if I put a number 1 in that B area, I got 2 pi divided by 1. That means this whole graph will be done by 2 pi. And does that make sense? If I look, starts at 0, goes up, comes down 2 pi. What shall it do next? Goes up, comes down 4 pi. What
Yeah.
shall it do next?
Goes up, goes
comes
down 6 pi.
6 pi, right? Or vice versa. Goes down, comes up, negative pi, 2 pi.
Yeah.
And so on and so forth, okay? So when you're talking about that, now the last thing is it could have a plus C, meaning you shift it up or down. Pick it up, put it down, okay? So if I'm looking at, let's say I'm going to graph, because this is a regular sine wave, let's say I'm going to graph 2 sine of 2x, okay? So my normal sine wave is this one here in black, okay? Its amplitude, it goes as high as 1 and as low as 1 for a normal sine wave. What do you think this guy is going to do?
Multiply the amplitude by 2.
It's going to multiply the amplitude by 2. So it's going to go as high as 2 and as low as -2. Okay? Having said that, yeah.
So if that was -2, would it be the same thing?
What would negative do in front of an x squared?
Oh, become positive.
Well, no, like negative x squared, if I'm graphing, it flips it over the x-axis, right? So if I put a negative in front of here, this whole thing goes down for it. It goes down, then up. So it literally flips it over the x-axis.
Okay.
Okay? So what would my period here be for this red?
Pi.
How'd you get it?
2 pi divided by 2 is pi.
Okay, pi. So what does that mean? That means that this graph, it's still going to start at 0. It's going to go up and come down. Instead of going up and down to 2 pi, it's going to go up and down and be done by pi. Does that make sense? It shortens the wavelength, if that makes sense. Okay, so what would this red graph look like? Well, instead of going up to 1, it's going to go up to 2. And it's going to come down to -2. And it's going to be all done by pi. So what is that going to look like? It's going to come up, come down, come up. That is the graph of 2 sine of 2x. Bless you. Does that make sense? What if I put, for a minute, what if I put a fraction, what if I had put a fraction here? 2 sine of 1/2 x.
It'll
Right.
extend.
So it starts at 0 and it goes like this. 2 pi, 4 pi. It elongates it left to right, okay? So is everybody okay with what I just did so far, right? Now, the question here says it wants me to graph y equals 4 sine x minus 1. So the things that I look at, and it wants me to graph it from -pi/2 to pi/2. We'll get to that in a minute. Let's just do the normal for a minute, okay? So it wants me to do that. So the things that I need to think about is the amplified changed, is the B, the period, changed, and does it shift up, down, okay? So the first thing I need to look at in this case is the amplitude is 4. Do you agree? So what would that do to this graph?
It's going to make it skinnier.
It's going to make it thin, right? So it's going to go, rather than up to 1, rather than up to 2, it's going to go up to 4.
Yes.
Make sense?
Mhm.
Okay, now, how about the period?
Stays the same.
The period stays the same. So this graph would be done like the little black graph up here. It would be done by 2 pi. Did that make sense? Okay, because it's 2 pi divided by 1. And then finally, what does the minus 1 do to this thing?
Move it down.
It takes it, it lifts it, it shifts it down. So your new axis that you're working with is going to be at -1. So what used to go from 0 to 4, now will go from -1 to 3. And then from -1 to how far down? -5. Okay, yes.
So is it always going to be 2 pi over the b number?
Yes,
Okay.
always. And that's period. And that's true for sine and cosine.
Okay.
Okay, so let's go ahead and draw what that will look like. I'm taking that off because we have all the regular stuff, but we need to kind of see. Now this is going to go from pi over 2 to negative pi over 2. Having said that, I would suggest doing naturally from 0 to 2 pi and then finish the other piece, if that makes sense what I'm trying to say. Okay, so how high is this one going to go? It's going to go as high as 4. So 1, 2, 3, 4, right? And as low as 4. Is that true? Not really, because guess what? I have to shift it a little bit. So what my new axis is going to be, and I'm just going to do myself a little thing with a pencil, and I'm going to say that's my new axis, okay? And the whole thing ends by 2 pi, right? So it's going to come from here, it's going to come up to 3, right? And it's going to come down. So it's going to come up to 3, that was not even showing, up to 3, and then it's going to come down, and then it would come back up over there. But really I don't care. Why? Because I only care from negative pi over 2 to pi over 2. And then what would happen if I went in its reverse direction? How far down will this go? It would have to go down to 5, right? You guys told me that? So it's going to come down to there and then back up, right? So all that I care about, if I'm talking about this, all I care about is from there to there. And what did we say our range was before? Oh, really?
Why is between -5 and 3?
So it's between -5 and 3.
So
That's
those
a
are our
coincidence, right? That's our range. We just drew it. We just showed how it looks. Okay. Yes.
What if you just drew a graph and you just put that little line there? Like, how do they give you points for a graph?
How do they what?
Because, like, what if your graph looks ugly, you know?
I don't think they're going to look for how beautiful the graph is, but I do think they want you to know the concept.
Mm-hmm.
That you shift, you stretch, you whatever you do. Okay, so are we comfortable?
Mm-hmm.
Okay, now my next question is, if we look at the next part, obtain the expression stating both the domain and range, right? So here's my question to you. If they didn't give me my initial negative pi over 2 to pi over 2, would we have been able to find an inverse of that thing? Would we have been able, like if it went on to 2 pi? So this thing is going up, coming down, going up. Could I have actually found the inverse of this thing?
No.
Why not?
Because in order for it to have an inverse, it must be 1-to-1.
That's exactly right. And give me the definition of 1-to-1.
1-to-1 meaning that it's either increasing or decreasing. It's not going to increase and decrease or decrease and then increase.
Beautiful. From negative pi over 2 to pi over 2, can you see that it is 1-to-1?
Monotonic.
Monotonic, that's the old lady word, right? Monotonic meaning going in one direction. So we are indeed able to find the inverse of this thing. That's why they set it up from negative pi over 2 to pi over 2. So we have the ability to find part IV. Okay, so find the expression of it. Oh, let's do that now. Have I lost anybody, or are we all okay? We're good, right? Okay, so the first step is make f of x be y. So y equals 4 sine of x minus 1, right? That's the first part. Now what? Part 2. Swap the x and the y.
Yes.
X equals 4 sine y minus 1. Are we okay? Are we good? Next step, start to do what? Start to solve for y, right? So what am I going to do next? I'm
Add
gonna
one.
Add 1. Right, add 1. And then
Divide by 4 sine.
divide by... No, not
No.
by 4 sine. That was, you actually have to inverse sine that whole thing, right? So sine to the -1 of x plus 1 over 4 is y. And then call it what it is. F to the -1 of x. Okay.
And that was 4 points, but then the graph was only 2 points.
Well, we have the ratio, find the main range. Your ratio, we have 2 points
Same
right
thing with the
now.
range, but we already have the main range of the original, so we just flip flop.
I'm so proud of you guys. So say that slowly so everybody hears you.
Well, so the original, we have the domain and the range, so the inverse just switches the domain and the range, so all we have to do is the old domain is the new range. And the
Yeah.
old range is the new domain.
Exactly.
So negative pi over 2 is less than or equal to y is less than or equal to 1/2 pi. And then for x, it's going to be,
-5. So
yeah, negative 5 is less than or equal to x is less than or equal to 3.
That's exactly right. What once was the domain and range for the original, flip-flops for the new one. So, so the range, the domain, sorry, of the inverse, and the range of the inverse. So the range is the given domain, and we're going to talk about it in terms of y. And then the domain, the range would have been from -5 to 3. So it's going to be -5 is less than or equal to x is less than or equal
This was last week, David?
to. This is exact, yes. Isn't that crazy?
Yeah.
I think it was doable. And they all came back to me and said it was horrible. So,
Do they pass it?
some.
you know
It was. Well,
So you had to do all that work to be able to, because we got the graph before we did this work, but that just gave us
the 4 points.
okay. So you wouldn't be able to get everything just from doing the graph like that?
Right.
That kind of stuff.
In the past, I used to take, and what we do, I would do something called down phase, where if your grade was not a B or an A, I would down phase you for the sake of saving your GPA and call it pre-calculus. And with the introduction to EOC, that was awful. Do you want me to put one more on your edline account so you can access them, or?
Yeah,
Really? You go through it and do it?
Do you need me to help you?
I'll look at it.
Let me find a good one.